Hello and good day, grade 9 students. Welcome to a new day full of learnings. Before getting into the new lesson, let us have a review about our previous topic. Let's begin.
Parallelograms have two sets of parallel lines. Trapezoids only have one set at a time. A rectangle has four right angles. A rhombus has four sides that are equal. Squares have four equal sides and four right angles. Quadrilaterals have four sides and four angles. Parallelograms, rhombuses, trapezoids, squares and rectangles. And if you add the angles inside each of these, there will be 360 degrees. Parallelograms have two sets of parallel lines. Trapezoids only have one set at a time. A rectangle has four right angles. A rhombus has four sides that are equal. Squares have four equal sides and four right angles. Quadrilaterals have four sides and four angles. Parallelograms, rhombuses, trapezoids, squares and rectangles. And if you add the angles inside each of these, there will be 360 degrees.
Congratulations everyone. Are you ready for today's lesson? In today's discussion, we're going to focus on solving problems involving the relationship of sides and angles in a parallelogram, trapezoids, and height using their properties and theorem. We need to remember all the definition, properties, and theorem that we have already discussed regarding parallelogram, kite, and trapezoids. But before that, let us remember some of the etiquette that we should know.
Online etiquette. Stay on mute. Be a responsible user. Don't distract others. Keep your camera on. Final reminders to keep in mind.
Thank you very much for listening. So let us now proceed to our topic, solving problems involving parallelogram, trapezoids, and kites. Now, since the topic is about solving problems involving parallelogram, trapezoids, and kites, the question is, how to solve this kind of problem? Now, in order to solve this kind of problem, we need to follow some steps. Step number 1, read the problem carefully. Step number 2, recognize the relationship of the given figure. Step number 3, pay attention to the levels. Step number 4, use appropriate definition, property, postulate, or theorem. And the last, answer the question. In short, we need to understand the problem. Read it twice, read it thrice, until we understand the problem. Now, let us now proceed to example number 1 and use a parallelogram wish. Now, if the problem is, if the measure of angle W equals x plus 15 degrees and the measure of angle S equals 2x plus 5 degrees, then what is the measure of angle W? Now, let's now draw the graph, or let us now draw the figure of a parallelogram wish. Now, from the given, the measure of angle W equals x plus 15 degrees and the measure of angle S equals 2x plus 5 degrees. So what is the measure of angle W? Now, one of the property of a parallelogram is any two opposite angles of a parallelogram is congruent or are congruent. So meaning to say that the measurement or the measure of angle W is congruent to the measure of angle S. So meaning to say that the measure of angle W is equal to the measure of angle S. Now, since W is congruent to angle S, so therefore it becomes x plus 15 degrees equal to 2x plus 5 degrees. Now, to simplify now this kind of problem or equation, we need to apply addition property of equality. So meaning to say that we're going to combine now 2x and x, 15 and 5, and that is by addition property of equality. By simplifying, 2x minus x equals x, and 15 minus 5 equals 10. So therefore, the value of x equals 10. Now, since the problem is about the measurement of angle W, so we need to substitute now 10 as the value of x. So, the measurement of angle W equals x plus 15, and by substitution, so it becomes the measurement of angle W equals 10 plus 15, and the measure of angle W equals 25. Now, any question about example number 1? Now, let us now proceed to example number 2 and use again a parallelogram which. Now, the problem is, if the measure of side WI equals 2x plus 5 and the measure of side SH equals x plus 28, then what is the value of x? Now, one of the properties of a parallelogram, any two opposite sides of a parallelogram are congruent. So meaning to say that the measurement or the length of side WI is equal to the length of side SH. So 2x plus 5 equals x plus 28. So let us now write the equation. 2x plus 5 equals x plus 28. By applying now addition property of equality, so it becomes 2x minus x and 28 minus 5. Now simplify. 2x minus x equals x and 28 minus 5 equals 23. So therefore, the value of x equals 23. Any question about example number 2? So let's now proceed to example number 3, but this time we're going to use now a trapezoid POST, which is not a parallelogram. Given isosceles trapezoid POST with side OS parallel to side PT and ER is the median of the trapezoid. So this is the given or the problem. If side OS equals 3x minus 2 and side PT equals 2x plus 10 and the median of the trapezoid equals 14, then how long is each base? Now, to solve now this kind of problem, of course, we're going to follow the midline theorem or the median of the trapezoid or the theorem of the median of the trapezoid, which is ER as the median of the trapezoid equals 1/2 times the quantity of side OS plus side PT, meaning the length of the midline or the length of the median of the trapezoid equals 1/2 the sum of the measure of each bases. Now, let us now substitute. The measure of side ER or the median of the trapezoid is 14 equals 1/2 times the measure of side OS plus the measurement of side PT. Now, to simplify, of course, we're going to multiply both sides by 2 so that 14 becomes 28 and the right side of the equation becomes 1 times the quantity of 3x minus 2 plus 2x plus 10. And by addition property of equality, So it becomes 3x plus 2x equals 5x, and negative 2 plus 10 equals 8. Combine again like term. So it becomes now 28 minus 8 equals 20 equals 5x. And then by division property of equality, we need to divide now both sides by 5. So the value of x now equals 4. Now the question is, what is the length of each bases? Let us now get the measurement of side OS, which is 3x minus 2. Substitute 4 as the value of x. It becomes now 3 times the quantity of 4 minus 2. And 3 times 4 equals 12 minus 2. So the answer is 10. Then how about side PT or base PT? The measurement of side PT equals 2x plus 10. Again, we're going to use now 4 as the value of x. So it becomes now 2 times the quantity of 4 plus 10. And then simplify. So it becomes now 2 times 4 equals 8 plus 10. So the answer is 18. Any question about example number 3? So let us now proceed to example number 4. So this time, we're going to use another example of quadrilateral, which is not parallelogram, and at the same time, not a trapezoid. So this is an example of a kite. Given, quadrilateral-like is a kite with side LI congruent to side AK and side LE congruent to side KE. The problem is, side LE is twice side LI if each perimeter is 21 cm. How long is side LE? Now, the perimeter of a kite equals 2s sub 1 plus 2s sub 2. By substitution, it becomes 21. Why? Because according to the problem, the perimeter of a kite is 21 equals 2Li plus 2 times the quantity of 2Li. Why? Because one of the from the problem, the measurement of Le is twice as long as Li. Okay? Let us now simplify. Now 21 equals 2s sub 1 plus 4 Li. By combining like term, meaning s sub 1 is the same as Li or said Li, so it becomes 21 equals 6 Li, meaning we're going to combine now like term. Divide both sides by 6, so it becomes 3.5. So the measure of Li equals 3.5, so therefore, if the measurement of LE is twice the measurement of LI, so therefore, LE equals 7 cm. So let us now proceed to example number 5. Let us use again a kite like. Now given, quadrilateral like is a kite with LI congruent to IK and LE congruent to KE. Now the problem is, what is the area if one of the diagonal is 4 more than the other and IE plus LK equals 16 inches? So we are looking now for the area. Now since IE or side IE or diagonal or segment IE plus diagonal LK equals 16, and from the statement that one of the diagonal is 4 more than the other, so it becomes now x plus 4 equals 16. And by combining like term, we're going to add x plus x, it becomes now 2x plus 4 equals 16. Then combine again like term, or by addition property of equality, so it becomes now 2x equals 16 minus 4. And the value of 2x equals 12. Why? Because it becomes 16 minus 4. Divide both sides by 2, and the value of x now equals 6. But the problem is about the diagonal. So the area of a kite equals 1/2 times the product of each diagonal. So 1/2 times d sub 1 times d sub 2. By substitution, area of a kite equals 1/2 times segment IE times segment LK. Area of a kite equals 10 times 6. Why it become 10 times 6? Why? Because according to the problem, the measurement of one of the diagonal is 4 more than the measure of the other. So it becomes now, if the first diagonal is 6, then the other diagonal is 10. Or it is also the same as 1/2 times 6 times the quantity of 10. And then it becomes 1/2 times 60. So it becomes now 30 square inches. Any question about problem number 5?
Is there any question about example number 1? How about example number 2? Example number 3? How about in example number 4? In example number 5? If there's no question, let me check if you understand our topic for today.
So let me check everyone if you understand the topic. I have here 5 problems for you to compute. The direction is illustrate and solve the following problems. So we have 1 to 5. I will give you a couple of seconds to compute. Then after that, I will show you the answer for you to check if your answer is correct or not. Are you ready? So let us start in number 1.
Congratulations everyone, because I know that you learned a lot from our topic today. Always remember, learning never stops. So please copy your assignment and then pass it tomorrow.